Okay, so we're going to prove that the sum of two odd numbers here is always even. So when you think about two odd numbers, 1 and say 9, okay, that's just a pair of odd numbers there. That adds up to 10, so that's even, isn't it? 17 add 3, yeah, they're two odd numbers. So add up to 20, that's even, yeah, you know, it's always going to work, okay, but we've got to prove it. Okay? We can't try every example because there's infinite amount. So what I'm going to do is I'm going to consider the first odd number. Okay, I'm going to think about is, well, if you remember the definition for odd numbers, it's like 2n plus 1, isn't it? So 2n plus 1, so it'll be, first odd number I'm going to look at is 2k plus 1, for where k is a constant. Okay, and the second odd number, I'm just going to change the letter basically. So again, just before, 2p plus 1, okay, where p is a constant. So then if I consider the sum of them, okay, well, I've got 2k plus 1 plus 2p plus 1. That becomes then 2k plus 2p plus 2. So I put the sort of letter terms side by side, 2k plus 2p, but then the constants can be added, can't they? So I get 2k plus 2p plus 2. I can't simplify that any further, but again, just what we had before, you'll notice 2 is a common factor, so I can factorize out 2, create a bracket, okay, because 2 is a common factor, so 2 times k times p, and then of course to get 2 times 1, isn't it? So I've got that there, and what you should see there, and that means it's a multiple, yeah? It's the sum is a multiple of 2, because you've got to times 2, you've got to times 2 by something to get this sum. Okay, so it's a multiple of 2, which means it's even.